Okay, we are doing something today called synthetic division. It looks a little crazy at first, but typically after students have done a few problems and have caught on, they tend to really like this and are really good at it. So it is kind of overwhelming at first. So this is a method of dividing. So we are going to have a polynomial today, and we are going to divide it by some kind of binomial, something with two terms, 1, 2. So one thing I want you to know about synthetic division, you can only use it if you're dividing by something that has a 1 in front of the x. If it doesn't have a 1 in front of the x, you have to use something called long division, and that you're going to learn about in Algebra 2. Okay, so today we're going to just work with synthetic division. So this front page kind of talks you through it a little bit, but it's kind of confusing. So I don't know if I want to do it with this problem until maybe you've seen some others. Okay, so let's just go to where the problems are, and then I might come back and show you this one. Okay, so first, whatever you're dividing by, you have to figure out what would you get if you set that equal to 0. You get -1. You would subtract 1 from both sides and you get -1. So that's called your 0. Remember the last lesson? Whenever you had the problem factored, let me find a good one. Whenever you had the problem factored, you set those factors equal to 0, and what you got were called your zeros. Okay, so when you set that equal to 0 and solve, you get -1. Well, that's called your 0. So first you put your 0 in the box. I have a song for this, and so if you watch me teach it in class, you'll get to hear the song. And then you pull down the coefficients, drop, drop, drop. Okay, so whatever this is, you're going to bring down all the numbers that you see. So there's a 1 in front of this x cubed. You just don't see it, so we write a 1. Then there's a 4 in front of the x squared, so we write a 4. And then there's a 1 in front of the x, so we write a 1. And then our constant's -6. So you do have to make sure whether they're positive or negative. Okay, then we draw this little line. And then this is how it goes. You bring down your first number. So I just bring this number down. So if this is a 1, this is a 1. If this is a 2, this is a 2. If this is an 8, this is an 8. If this is a 21, this is a 21. Okay, then we start this sequence of multiplying, adding, until we're done. So I'm going to multiply these. So whatever's under the line with what's in the box. So 1 times -1 is -1. And then whatever's above the line, I add. So 4 plus -1 is 3. Then I go back to multiplying what's under the line with what's in the box. So 3 times -1 makes -3. And then I add the numbers above the line. So 1 plus -3 is -2. Then I go back to multiplying. -2 times -1 makes a +2. And then I go back to adding. And -6 plus 2 makes -4. Okay, this last number is always our remainder. So I'm going to make a little note of that. And then I'm going to show you how to write this answer. Okay, so this first part won't really make sense to you, so you'll just have to kind of believe me. Now, when I teach this lesson live in class, I will try to explain this. But to keep the video a little bit shorter, I'm just going to kind of get into this is how you do it. So whatever the exponent starts off as in your problem, this first number is always going to be in front of an x with an exponent that's 1 less. So if it starts out with a 3, then the answer will be a 2. If the exponent's a 4, this would be a 3. If this was a 6, this would be a 5. If this was a 20, this would be a 19. So your answer's first exponent will always be 1 less than the original. And then you go in order from there. So you know how in a problem After an x cubed comes an x squared. After an x squared comes an x. After an x comes a constant. So we need a decrease in order like that. So after an x squared comes an x. So this positive 3 is in front of an x. After an x comes the constant. So this negative 2 is the constant. And the last number is the remainder. So since it's negative, I put minus. And then the remainder always goes over whatever it is that you're actually dividing by, which is x plus 1. So the remainder goes over x plus 1. And that's our answer. And I know it's kind of crazy. And some other lessons down the road, we're going to hope that the remainder is 0, because when the remainder is 0, we can do more with the problem. And we'll actually talk about some of it today, but we'll talk more about it later. Okay, let's try it again. It's kind of weird, but it's really not difficult. And like I said, most students tend to love it after they've done it a few times. All right, so you start with what you're dividing by. If you set that equal to 0, what do you get? You get a positive 3, because you would add 3 to both sides. So that's called your 0. So first you put the 0 in the box. Then you pull down the coefficients, drop, drop, drop. So first I have a 5, then I have a negative 6, then I have a 4, and then I have a negative 1. Okay, draw your line. So we bring down this first number. Whatever this first number is, bring him down. And then we multiply, add, until we're done. So 5 times 3 is 15. And then you add. So negative 6 plus 15 is 9. Then go back to multiplying. 9 times 3 is 27. Then go back to adding. 4 plus 27 is 31. Then you go back to multiplying. And 31 times 3 is 31 times 3 is 93. And then you go back to adding. And negative 1 plus 93 is 92. Okay, remember, this last number is always the remainder. Okay, so let's see if we can figure out how to write our answer. All right, this one started off x cubed. So this 5 will be in front of an x squared. It's always going to be 1 less. So then after an x squared comes an x. So this 9 is in front of an x. After an x comes a constant. So that 31 is the constant. And the last number is the remainder. This time it's positive, so I'm going to put a plus. And then the remainder goes over whatever it is that you're dividing by. And you're dividing by x minus 3. So x minus 3 goes right here. And that's our answer. Looks kind of ugly, but that's what it is. Okay, are you catching on? Okay, let's keep trying. Let's go to number 4. So first, who do you think you'd put in the box? Positive 3. Yeah, if you set x minus 3 equal to 0, you'd add 3 to both sides and you get a positive 3. So first you put the 0 in the box. Then you pull down the coefficients, drop, drop, drop. So I've got a negative 2, positive 15, negative 22, negative 15. Okay, then draw your line. And then you bring down the first number. So whatever this first number is, I just bring it down. Then I start my sequence of multiplying, adding, until I'm done. So negative 2 times 3 is negative 6. And then I add these numbers. So 15 plus negative 6 is 9. Go back to multiplying. 9 times 3 is 27. Then I go back to adding. And negative 22 plus 27 is 5. And then I go back to multiplying. 5 times 3 is 15. And then I go back to adding. And negative 15 plus 15 is 0. Okay, so now let's just write our answer. So it started off with x cubed, so this negative 2 is in front of an x squared, always one less. The 9 is then in front of the x, the 5 is then the constant. This last number is always the remainder, and if your remainder is 0, you don't have to write it at all. Now, I wanted to talk about getting a remainder of 0, what that does, because we're actually going to talk about it down below. So, if I wanted to find all the zeros of this, I know one of the zeros is the positive 3. Well, because I got a remainder of 0, then if I was to solve this, I'd get all the other zeros. And so I could try to factor this, or I could try to use quadratic formula if factoring didn't work, and I could get all the zeros. So synthetic division gives us a way to figure out all the zeros to a problem. Okay, now let's look at this first problem that was on this front page and just see if we can fill in the boxes right here. Okay, so they were dividing by x plus 1, and if you set that equal to 0 and solve, you would subtract 1 from both sides and you get negative 1. So that's why you see negative 1 in the box. And then they pulled down the coefficients, drop, drop, drop. So that's why you see 3, negative 4, 2, negative 1. Okay, then you bring down the first number. So they've already done that. Okay, now what? Multiply. 3 times negative 1 is negative 3. Now what? Add. Negative 4 plus negative 3 is negative 7. Now what? Multiply. Negative 7 times negative 1 is positive 7. Now what? Go back to adding. 2 plus 7 is 9. Now what? Go back to multiplying. 9 times negative 1, negative 9. And then go back to adding. Negative 1 plus negative 9 is negative 10. And that's my answer. I just have to know how to write it. And so down here, you kind of see it all worked out for you, except the last little piece. And I don't know, I think I had it there at once, but I don't know why. So this remainder just needs to be written over whatever it was you were dividing by, which was x plus 1. And that would be the answer to this problem. Okay, let's go back to the other page. So now I need to show you one that's different. Let's look at 6. It's different. Is there any reason why you think it's different? First, who's your 0? Who would you put in the box? Negative 3. If you take what you're dividing by and set it equal to 0, you would subtract 3 and you get negative 3. Okay, so maybe you notice that this doesn't have as many terms as this. So this is when I need to talk about something we haven't had to deal with yet. It doesn't matter what a problem starts with. So let's say a problem starts with x to the 5th. If it starts with x to the 5th, it has to have everything below it. It has to have x to the 4th, x cubed, x squared, x, and constant. Let's say it starts with x cubed. That's what all of ours have started with today. If it starts with x cubed, it needs an x squared, it needs an x, and it needs a constant. So it doesn't matter what the problem starts out as, but it has to have everything underneath it. So if it starts with x to the 7th, for example, it would have to have an x to the 6th, an x to the 5th, an x to the 4th, an x cubed, an x squared, an x, and a constant. So let's look at this problem. Let's see, does it have everything below it? No. It starts with x cubed, which is fine. It can start with whatever. Does it have an x squared below it? Nope, there's no x squared. Does it have the x below that? Nope, there's no x below that. And then it does have the constant. So it's missing the x squared and it's missing the x. Okay, so we have to take that into consideration. So in front of the x cubed is a 1, but because there's no x squared, we have to put a 0. And because there's no x, we have to put a 0. And then the constant is a 27. So this would be the x cubed, the x squared, the x, the constant. So I didn't have to do that on the other problems because they always had everything. X cubed, x squared, x constant. X cubed, x squared, x constant. But this one was missing the x squared and the x, so we had to put a 0 for both of those that were missing. Now I can work the problem. So bring down the first number. So I bring down the 1. Now let's multiply. 1 times -3 is -3. Add them up. -3. Multiply. 9. Add them up. 9. Multiply. -27. Add them up. 0. Okay, now let's write our answer. It started off x cubed, so this 1 is in front of an x squared, always 1 less. The -3 is in front of the x, the 9's the constant, and the 0 is the remainder. And if your remainder is 0, you don't have to write it. Okay, so now I'm going to show you two problems where we're going to use synthetic division, just like we've been doing all class, and then we are going to completely factor this problem. So let me show you how that's done. So first I'm going to do synthetic division like normal. So I am taking this and I want to divide by that. So who's your 0? Who are you putting in the box? -2. If you set that equal to 0, you'd subtract 2. So first you put the 0 in the box. Now let's see. Is it missing anything below the x cubed? Nope, it's got x squared, it's got x, it's got the constant. Okay, so I don't need any zeros for fillers. So I've got a 1, I've got a -2, I've got a -5, and I've got a 6. So let's begin. So bring down the first number, multiply, -2, add, -4. Multiply, +8, add, +3, multiply, -6, add, 0. Okay, let's write our answer. It starts off x cubed, so this 1 is in front of an x squared, the -4 is in front of an x, the 3 is the constant, and if your remainder is 0, then you don't have to write it. Okay. So when you get a remainder of 0, what it means is what you divided by is a factor and your answer is a factor. So if I want to completely factor this problem, then I need to factor my answer. So let's do it. We've got 3 terms. There's no GCF, so we're going to A times C rooftop. So what's A times C here? 1 times 3 is 3. What do we want them to add to make? -4. And do you know what multiplies to make 3 and adds to make -4? -3 and -1. -3 times -1 is +3, and -3 plus -1 is -4. Okay, because it's the easy one, I get to go straight to the parentheses, write down the letter I'm working with, and write down the numbers I found. -3, -1. And then the thing I divided by is also a factor, so I'm going to bring down my x plus 2. So now I have completely factored this problem. So from here, this is not asking me to do this, but from here I could find all the zeros if I wanted. What would you get if you set x minus 3 equal to 0? You'd get a +3. What if you set x minus 1 equal to 0? You'd get a +1. And what if you set x plus 2 equal to 0? You'd get a -2. And those would be all the zeros to this problem. So if I graphed this, I would see this graph touch the x-axis at 3, at 1, and at -2. So synthetic division, it helps us if we get a remainder of 0 by completely factoring a problem and finding the zeros. Now granted, I could have put this in the calculator and found the zeros just as easily. But sometimes the zeros don't come out so pretty, which we're going to see in future lessons, but the synthetic division will still help us in the process. Okay, one more. All right, do you know who we're putting in our box? First, you put the 0 in the box. -4. Pull down the coefficients, drop, drop, drop. I've got a 1 in front of the x cubed. You notice anything? There's no x squared. It's missing the x squared. So since there's no x squared, we need to put a 0 to fill it in. After the x squared comes the x, so -13. And after the x comes the constant, so 12. So this little 0 is going to get some of you. So just make sure that there's always everything underneath. X cubed, x squared, x constant. And if it's missing something, you have to put in zeros. Okay, bring down the first number. Multiply. 1 times -4 is -4. Add them up. -4. Multiply. +16. Add them up. +3. Multiply. -12. Add them up. 0. And so now let's write our answer. So it started off x cubed. So this 1 is in front of an x squared. The -4 is in front of the x. The 3 is the constant. And 0 is the remainder. Well, if you'll notice, we just got the same answer that we got over here. So I already know how this factors. So I know it factored with an x -3 and it factored with an x -1. But what you divide by is also a factor, so we need to bring down the x + 4. And now it's completely factored, which is what the problem wanted us to do. And from here, I could find the zeros if I wanted. Let's just do it because it's just so easy. What do you get if you set x -3 equal to 0? +3. Set x -1 equal to 0? +1. Set x + 4 equal to 0? -4. And those would be your zeros. And this is synthetic division. Did you like it? I hope you did. That's it. Smiley face.